Propositions on parallel lines. In this module, you will learn some propositions on parallel lines. First, look at Proposition 1. If a transversal cuts two parallel lines, then the sum of two interior angles on the same side of the transversal is equal to 180 degrees. Suppose a transversal AB intersects two parallel lines PQ and RS at M and N respectively. These are the angles made by the two lines. Now, you have to prove that the sum of the interior angles on the same side of the transversal is equal to 180 degrees. That is, you have to prove that angle 3 plus angle 5 is equal to 180 degrees and angle 4 plus angle 6 is equal to 180 degrees. Now, look at the proof. Suppose angle 3 plus angle 5 is not equal to 180 degrees. Then, angle 3 plus angle 5 is either less than 180 degrees or greater than 180 degrees. Suppose angle 3 plus angle 5 is greater than 180 degrees. Consider the sum. Angle 3 plus angle 4 plus angle 5 plus angle 6. Angle 3 plus angle 4 is equal to 180 degrees. Similarly, angle 5 plus angle 6 is equal to 180 degrees. 180 plus 180 is equal to 360 degrees. Thus, you have angle 4 plus angle 6 is equal to 360 minus angle 3 plus angle 5. As you have assumed angle 3 plus angle 5 to be greater than 180 degrees, so 360 minus angle 3 plus angle 5 is less than 180 degrees. Thus, angle 4 plus angle 6 is less than 180 degrees. Since angle 4 plus angle 6 is less than 180 degrees, according to Euclid's fifth postulate, the lines PQ and RS will meet on the right-hand side of AB. You can thus see that if the sum of the interior angles on the same side of a transversal is not equal to 180 degrees, then PQ and RS meet at some point, that is, either left or right of the transversal. Thus, if PQ and RS are parallel, the sum of the interior angles on the same side of the transversal is 180 degrees. That is, angle 3 plus angle 5 is equal to 180 degrees. Similarly, angle 4 plus angle 6 is equal to 180 degrees. Now, look at Proposition 2. If a transversal cuts two distinct straight lines in such a way that the sum of two interior angles on the same side of the transversal is equal to 180 degrees, then the two lines are parallel to each other. It is given that the sum of angles on the same side of the transversal is 180 degrees. Suppose PQ and RS are two straight lines and a transversal AB intersects them at M and N respectively, such that angle PMN plus angle RNM is equal to 180 degrees. To prove, PQ is parallel to RS. Now, look at the proof. This will be proved by contradiction, that is, by assuming that PQ is not parallel to RS. This means that PQ and RS meet at a point, say C. Now, according to Playfair's postulate, given a line in a plane and a point outside the line in the same plane, there is a unique line passing through the given point and parallel to the given line. Thus, there exists a unique line DE such that DE is parallel to AB. Now, angle DCM plus angle AMC is equal to 180 degrees as they are interior angles on the same side of the transversal. Also, angle AMC plus angle CMN is equal to 180 degrees as they are supplementary angles. From these two equations, you get angle DCM is equal to angle CMN. It is given that angle CMN plus angle MNC is equal to 180 degrees. From the two equations, you get angle DCM plus angle MNC is equal to 180 degrees. Now, angle DCN plus angle MNC is equal to 180 degrees. From the two equations, you get angle DCM is equal to angle DCN. Angle DCN is equal to angle DCM plus angle MCN. Using these two equations, you get angle DCM is equal to angle DCM plus angle MCN, which implies that angle MCN is equal to 0, which further implies that CQ and CS coincide. This contradicts that PQ and RS are distinct lines. Thus, PQ is parallel to RS. In this module, you have learnt some propositions on parallel lines.